Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering at Institute of Aeronautical Engineering. So in today's class, we are going to discuss some numerical problems based on the single phase AC circuits. So in the previous class, we have already discussed about the concept of single phase AC circuits in case of pure resistive load or pure inductive load and pure capacitive load, and as well as we have also discussed a combination of resistor and inductor and as well as the resistor and the capacitor. So based on those concepts, now in today's class we are going to discuss some numerical problems. So let us go with the first problem. So let me read this first problem. The first problem is about calculate the reactance of a coil of inductance 0.32 henries when it is connected to a 50 Hz supply. And then in that again one more problem is there, and a coil has a resistance of reactance of 124 in a circuit with a supply of frequency of 5 kHz determine the inductance of the coil. So which means in the first case they ask us to calculate the reactance of a coil of and for that particular coil they have given the inductance, which means L is equal to 0.32 henries and the frequency which is given 50 Hz. Then they ask us to find the reactance. So which means the inductive reactance. We know already that is XL is equal to 2 pi F into L. So we know what is F value and what is L value. You just substitute, then you will get the XL value, which is the reactance of a particular coil. So here this is what here the XL is equal to 2 pi into FL. Just substitute the value of F here, it is equal to 50 Hz and L here it is equal to 0.32. Then if you simplify this equation, then you will get the inductive reactance of a particular coil is 100.05 ohms. Right. So next in the second question, a coil has a reactance. So which means XL which is equal to 124 and in a circuit with a supply frequency F is equal to 5 kHz. Then determine the inductance L. Okay. So from this equation, if you send this 2 pi FL to the left hand side, then you will get L is equal to what is that? XL by 2 pi F. So this is what you just substitute these values because L is equal to XL by 2 pi F. You substitute the value of XL which is equal to 124 and 2 pi into F. So F is 5 kHz. So which means 5 into 10 to the power of 3. If you simplify this, then you will get the inductance of that particular coil is 3.95 millihenries. So this is how we can calculate the variables, right? So simple, we applied the in case of pure inductance, right? Then coming to the problem 2. A coil has an inductance of 40 millihenries and negligible resistance. So calculate its individual reactance and the resulting current of current if connected to a 240 volts 50 Hz supply and 100 volts 1 kHz supply. So which means here what they are asking to calculate, of course, as we know I is equal, they are asking us to find the current. So here the equation for the current I is equal to, which is VL by XL. So VL we know that is 240 volts, okay, but XL we don't know. So again by using the same equation which we have already used in the previous case, 2 pi F into L. So L is 40 millihenries. Then substitute, so you will get XL value in the first case which is equal to 12.57 ohms, right? Because in the first case here the frequency is 50 Hz, right? Then IL is equal to here, I is equal to V by XL. So V is 240 volts, just substitute the 240 and XL here we got the XL value which is 12.57. Then if you simplify this, then you will get 19.09 amperes. So in the next case, second case, of course in the second case the XL will vary because here the frequency is 1 kHz. Then again you need to find the XL value in this case by substituting the frequency as a 1 kHz. So if you substitute the 1 kHz, then here it is 1 into 10 to the power of 3, and anyway here again the 40 millihenries, which means 40 into 10 to the power of minus 3. If you simplify this, then you will get which is 251.3 ohms. Then here substitute this 251.3 ohms again in the same equation. Current I is equal to V by XL. Then here V is, of course, in the second case here it is 100 volts. So substitute 100. By Excel value we have calculated here, that is 251.3. So substitute all these two values, then you will get the I value as a 0.398 amperes. Right? So this is how we can find the value of the current also. So till now we discussed two equations. One is this one, another one is this one. Right? Again, here also we no need to remember the equations. You just understand the concept. So just by applying the concept that we understood, then you will get these equations. Then coming to the problem 3. Determine the capacitive reactance of a capacitor of 10 microfarads when connected to a circuit of frequency 50 Hz and 50 Hz and 20 kilohertz. So in this case, which means we have to find the value of Xc. Xc is equal to 1 by 2 pi Fc, that we have discussed in the previous class. Just see here the direct problems. Okay, you need to just substitute in these equations, then you will get the answer. Right? So that's what here. So Xc is equal to 1 by 2 pi Fc. So here 2 into pi F. In the first case, let us consider the 50 Hz. So wherever the F is there, you just substitute 50 Hz. And again, here 10 microfarads. So micro means 10 to the power of minus 6. So 10 into 10 to the power of minus 6. Then by simplifying this, then you will get here, it is 318.3 ohms. That is the capacitive reactance. Then second case, of course, instead of 50 Hz, you just substitute the 20 kilohertz, which means 20 into 10 to the power of 3. Then you will get the answer. In the second case, here it is 0.796 ohms. See how simple the problems are. So only the thing is, we have to understand the concept. So based on the concepts, then we can remember the equations, and by substituting the given information in the equations, then we can get the solutions. Then coming to the problem 4. A capacitor has a reactance of 40 ohms. When operated on a 50 Hz supply frequency, determine the value of the capacitance. Of course, again for this also the same equation. Of course, here the given capacitor has a reactance. So which means Xc is equal to 40 ohms, that is the given, and F is equal to 50 Hz. So what we have to find, determine the value of the capacitance, which means C is equal to how much. Then we know the equation Xc is equal to 1 by 2 pi F into C, right? So you just send this to this side, okay? So that here C is equal to 1 by 2 pi F into Xc. Then substitute the values here. 1 by 2 pi into Xc. So here F value that they have given here, it is 50 Hz, so 50, and Xc value that they have given 40. So substitute the 40, then you will get the capacitance value. The capacitance is, here it is 79.58 microfarads. So this is the problem 4. Next, fifth problem. So calculate the current taken by a 23 microfarads capacitor when connected to a 240 volts and 50 Hz supply. Of course, the same way here, which means I is equal to V by Xc. Right? So here what is Xc? Xc is equal to 1 by 2 pi Fc. So first we have to find Xc value, or otherwise directly you can rewrite this equation like this. So here if you send this to the upside, then it will get 2 pi Fc into V. Then substitute all the values. Here F is equal to 50 Hz and C is 23 microfarads, so 23 into minus 6, and again here V is 240. Okay, then if you simplify, then you will get, here it is 1.73 amperes. That is the current flowing through that particular circuit. Next, coming to the problem 6. In a series RL, now we are coming to the next circuit, which is series RL circuit. So in a series RL circuit, the potential difference across the resistance R is 12 volts and the potential difference across the inductance L is equal to 5 volts. And find the supply voltage and the phase angle between the current and voltage. Again, very simple here also. So first let me write the given data. So here it is VR, the voltage across the resistance, here it is 12 volts. And the voltage across the inductance VL is equal to 5 volts. Then find the supply voltage. Of course, we know that V is equal to VR plus VL. But of course, this is the phase, the vector addition, not the simple addition. Okay, so that we need to remember. So which means the vector addition means, okay, so usually the vector V is equal to here VR plus VL. Okay, or in another words that we have already found VR plus JVL, right? So which means here then V is equal to square root of VR square plus VL square. So that's what here. Okay, VR is equal to 12 and VL is equal to 5, then VR square plus VL square is equal to 13 volts. So this is the supply voltage. Or otherwise simply you can find from this power triangle also. Okay, so this is the total voltage and this is VL is equal to IL into XL and this is VR is equal to I into R, because as we know the phase difference between VL and VR is 90 degrees. So that's why here then, but this is the resultant voltage. So the resultant voltage here it is, this is the phi. So this is the actually the phase angle between the voltage and currents, right? So from this power triangle or from this voltage triangle, we can also call it as a voltage triangle. If we represent in terms of power, then it will be a power triangle. But anyway, here it is voltage triangle. So from this voltage triangle also, V is equal to square root of VL square plus VR square, right? So substitute the values, then you will get the total supply voltage across the series combination of RL circuit. Here it is 13 volts. Then coming to the power factor, okay. So the power factor here it is VL by phi is equal to VL by VR, that we already know. Okay, just substitute 5 by 12. Okay, and then here it is, of course, here it is the tan inverse. So the tan inverse 5 by 12 here it is 22.62 degrees. So which is around 22.62. Here it is lagging, because anyway, as we know RL, in case of RL circuit, that is the lagging. Okay, right? So this is how we can find the total voltage and well as even though we can find the power factor also, because phi once we know, then cos phi is the power factor. So cos 22.37 degrees is the power factor. That is how we can find. Then coming to the problem 7. So a coil has a resistance of 4 ohms and an inductance of 9.55 millihenries, and calculate. First question is the reactance, and the second question is the impedance. Third question is the current taken from 240 volts and 50 Hz supply, determine also phase angle between the supply voltage and current, right? So this is also very simple. Again, first the given data here it is R, which is equal to 4 ohms, and L, which is equal to 9.55 millihenries. Okay, V, supply voltage 240 and the frequency 50 Hz. First what they are asked us to calculate XL. So XL is equal to 2 pi f into L. So you can just substitute. Then the second one is impedance. So Z is equal to R plus JXL, or in another words, Z is equal to square root of R square plus XL square. That is impedance. And current, I is equal to V by Z, right? And also phase angle. So by using these equations we can find. Let us see how. So the first one here it is. This is the given data that they have written. Then first problem, inductive reactance XL is equal to 2 pi f into L. So substitute all these values, then you will get the 3 ohms as the inductive reactance. Then the second one is the impedance. As I mentioned, Z is equal to square root of R square plus XL square. So just now we have calculated the XL value and R value we know. Just substitute in this equation, then you will get the impedance Z is equal to 5 ohms. Then the current I is equal to V by Z. Okay, that's what we have discussed. So Z is 5, V is 240 that they have given, then 240 by 5 is equal to 48 amperes. Simple. Then for this actually the circuit and the phasor diagram and the voltage and impedance triangles that we have already discussed. Of course, here they mentioned the figure 15.6, which means the same concept we have covered in the previous classes. Okay, so there you can see what is the power triangle and impedance triangle. So from that the tan inverse is equal to XL by R. Okay, tan phi, phi is equal to tan inverse XL by R. So here XL is equal to 3 and R is equal to 4. So 3 by 4 is equal to 36.87 degrees. This is how we can calculate the phase angle between the supply voltage and the current, right? Then coming to the 8th problem. A coil takes a current of 2 amperes from a 12 volts DC supply when connected to a 240 volts 50 Hz supply. The current is 20 amperes. Calculate the resistance, impedance, inductance, reactance and inductance of the coil. Okay, so which means here first of all resistance R is equal to the DC voltage by DC current. Okay, so first of all what is the DC voltage that they have given? 12 volts and 2 amperes. Then calculate the resistance means that we have calculated the resistance. Then impedance. Impedance means AC voltage by AC current, right? So AC voltage 240 that they have given, AC current 20 amperes that they have given, then impedance Z is equal to 12 ohms. Then the inductive reactance. Of course, we know that Z is equal to square root of R square plus XL square. So here 3 variables are there. Out of 3, 2 variables that we know, just substitute the 2 variables, then you will get the third equation. So which means XL is equal to square root of Z square minus R square, then substitute Z square as a 12. Okay, and R square R is a 6, then you will get the XL value is equal to 10.39. So the resistance we have calculated, impedance we have calculated, and inductive reactance we calculated. Now inductance. Of course, inductance, then XL is equal to 2 pi F into L. So L is equal to XL by 2 pi F. Then substitute all these values here. Then you will get the value of the inductance. L is equal to 33.1 milliamp. This is how we can calculate the various parameters which are present in the RL circuit. Then coming to the ninth problem here. Okay. So here in the ninth problem, let me read first. Of course, there are so many parameters that we need to calculate. A coil of inductance 318.3 millihenries and a negligible resistance is connected in series with a 200 ohms resistor to a 240 volts and 50 Hz supply. So from this statement, we can understand this is an RL series circuit, and calculate the inductive reactance of the coil and the impedance of the circuit and the current in the circuit and the potential difference across each component and the circuit phase angle. Of course, here also it is very simple. First of all, let us write the given data. So here this is the given data that L is equal to 318.3 and R is equal to 200, V is equal to 240 and F is equal to 50 Hz. Then inductive reactance means XL is equal to 2 pi FL. So substitute the value of L here and F also, then you will get the value of 100 ohms as a inductive reactance. Then coming to the impedance. So impedance Z is equal to, we know already, square root of R square plus XL square. So we know the R value and just now we have calculated the XL value. So if you substitute the both these values in this particular equation, then you can find the impedance Z is equal to 223.6 ohms. Then what is that? And then the next question here is the current. Of course, current I is equal to V by Z. Then we know V value and Z just now we have calculated, which is 223.6 ohms. Then substitute in this equation, then you will get the current is equal to 1.073 amperes. Then next one, the potential difference across each component. So the potential difference across each component means, of course, the current. So VL is equal to I into XL and VR is equal to I into R. Then substitute these two values here, then you will get the value of VL and VR value. So VL is 107.3 ohms and VR is equal to 214.6 volts. Right? So this is how we can find. Then finally we are going to the last one, that is the circuit phase angle. Okay, this is also in the previous problem we have discussed that phi is equal to tan inverse of XL by R. We know the XL value and R value. Substitute these XL and R value in this equation, then you will get the phase angle between the voltage and the current, that is phi is equal to 26.57 degrees. Then the final problem, which is problem 10 here, it is a coil consisting of a resistance of 100 ohms and the inductance of 200 millihenries, and if an alternating voltage V is given by V is equal to 200 sine 500 t volts is applied across the coil, then calculate the circuit impedance, the current flowing and the potential difference across the resistance and the potential difference across inductance and the phase angle between the voltage and current. Of course, almost we have to find the same parameters that we have calculated in the previous problem. But here the given data is having some the conceptual way, that is V is equal to 200 sine 500 t. So which means here it is V is equal to Vm sine omega t. So which means here omega is equal to 500. That is what they are giving the information. And similarly, already they have given R is equal to 100 ohms and L is equal to 200 millihenries. Now we have to find one by one. So first one is, of course, here they just mentioned 2 pi f, which is equal to 500 radians per second, the given data. Then after that, first of all, we have to find what is the circuit impedance. So the circuit impedance. So before going to find the circuit impedance, so here first of all we have to find the RMS value. V is equal to 0.707 into 200, because that they have given here it is Vm. So from this VM to VRMS that we need to find. Okay, so now we have converted the VM into VRMS. Then the because here the circuit impedance Z is equal to, as you know, square root of R square plus XL square. So but we don't know the value of XL. So to find, first we need to find the value of XL. So XL is equal to 2 pi FL. Or we can 2 pi F is nothing but omega. So already we know the value of omega. Then substitute here omega value and L value. Then you will get the value which is 100 ohms, that is the inductive reactance. Then first of all, then coming to the first bit, the circuit impedance Z is equal to square root of R square plus XL square. So substitute the value of R and XL here. R is equal to 100 and of course XL is equal to also 100. Then substitute and simplify, then you will get 141.4 ohms, which is the impedance. Then coming to the second bit, which is the current. I is equal to V by Z. So we know the value of V and Z value. V is here 141.4 volts and Z value here just now we have calculated, which is 141.4 ohms. Then substitute here, then you will get V by Z is equal to 1 ampere. Of course here, because the voltage and the impedance having the same value, so that's why you got the current as a 1 ampere. Then coming to the second bit, what is the potential across the resistor? The same way, I into R. So VR is equal to I into R, which is 1 into 100, then 100 volts. And the potential difference across the inductor, I into XL. Of course here, XL also we got the value of same 100. So that then 1 into 100 again 100 volts. Then the potential difference across the resistor and the potential difference across the inductor, both are 100 volts. Then the next one, the final one, is the phase angle between the voltage and current. Same way here, tan inverse XL by XR. Of course here XL and XR value is same. So you will get the tan inverse 1. So the tan inverse 1 is nothing but the 45 degrees. So this is how we can find the various parameters from the given data in the single phase AC circuits. Right? So this is all about the numerical problems. Okay. Same way, I mean, maybe some problems you may get on the circuit which is having a series capacitor and the resistor. Okay. In that case also the same thing. Okay. You need to just understand the concept, and by understanding that concept, you just derive the equations so that you can remember the equations and substitute the given values in that equation. Then you will get the unknown parameters. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.